When you are simplifying exponential expressions, there's a couple of tips and strategies that you can use. The first one is to apply the power of a power rule first if it is required. This is just using our order of operations, so the power rule would be like applying an exponent before multiplying. So power rule first, x to the 5th raised to the 3rd power is x to the 5 times 3, x to the 15th, times x to the 4th. So power rule first, that's my exponent, and now I will multiply using the product rule. X to the 15th times x to the 4th, we add our exponents to get x to the 19th. In the second example, again, we can use the power rule. Y squared raised to the 4th power gives me y to the 8th divided by y to the 3rd. Now, after having used the power rule, I can use the quotient rule and subtract my exponents. Second tip, if you're in a quotient rule situation, first simplify the numerator and the denominator separately. So in this case, we have two bases of w, two factors with a base of w, giving me w to the 11th, x to the 9th. In the denominator, I have two factors with an x with a base of w, giving me w to the 5th times x to the 7th. Now I can just use the quotient rule. So this is a really, really helpful tip. Simplify the numerator and the denominator separately. Using the quotient rule, 11 minus 5 is 6. 9 minus 7 is 2. And this is my preferred order of factors, alphabetical order, w to the 6 times x squared. Putting these two tips together, we are going to keep simplifying until each base only appears one time. So power rule first. Simplify the numerator and denominator separately. That's a 3, I think. So simplify the numerator and the denominator separately. And then now I'm just going to use the quotient rule. So power rule, numerator, denominator separately, and then here I just use the quotient rule. This part is just really a repeat of what we talked about on the quotient rule toolkit, but we want to simplify fractions rather than just doing 10 divided by 2, 12 divided by 3. That'll ensure that I have the coefficient in the numerator or denominator as required. So in this first case, 5 ends up in the numerator. In the second case, 4 is in the denominator because I think of this as simplifying the fraction 3/12 to 1/4. If you have a huge number when the power is evaluated, you're just going to keep it like this. 9 to the 17th has like 23 digits. We are not going to write those 23 digits down. Simplified 9 to the 17th is just 9 to the 17th. However, something reasonable like 2 to the 4th, you're going to go ahead and evaluate that. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we would want you to write 16 times x to the 15th in this case. So don't keep your number as a base if at all possible. Here's something we've also talked about before, but being really careful with negative signs. -3 in parentheses to the 4th is -3 times -3 times -3 times -3. -3 times -3, positive 9. Positive 9 times -3, -27. -27 times -3 is positive 81. And then here we have the product rule. In this case, since the negative is not in parentheses, the base is not -3. The base is positive 3 being multiplied by -1. That's going to give me positive 81 times -1, which is just -81. So it is absolutely crucial that you know the difference between -3 to the 4th, which is really just -1 times 3 to the 4th, and -3 in parentheses to the 4th, meaning -3 is my base.